In this video, I'm going to show you one sample question on how to apply Cramer's rule to solve simultaneous equation. Now I'm going to select one question which I've taken from the September 2007 exam questions part B, question 2, which carries 20 marks. Solve the following equation using Cramer's rule. So we are given three equations here with three variables, x, y and z. So in order to use the Cramer's rule, there are three steps altogether. The first step is to change the given equations into the matrix form of ax equals to b. So what we do is we copy the equation, and first we need to arrange these three equations starting with x and then followed by y and then z, right? So from here we will take out all the multiple of x, which is 1, 1, 2, right? So we write down 1, 1, 2, and then followed by multiple of y, positive 1, negative 1, and negative 1. So positive 1, negative 1, and negative 1, and then followed by multiple of z, which is 1, 1, 3. So we write as 1, 1, 3, then times the matrix x, y, and z equals to 6 to 6. So A will be this matrix 3 by 3, and then the 6 to 6 is matrix B. Okay, so step number 2, we need to find the determinant of A, A1, A2 and A3. Remember, if we are to find the values of three variables, we need to find determinant up to A3, okay, A1, A2 and A3. So let A equals to the matrix A given just now. Alright. Now from here, to find the determinant of A, we need to copy this matrix and then copy the first two columns, which is 1, 1, 2 and 1, negative 1 and negative 1. Then next step is to draw lines across these numbers, okay, and followed by 1 times negative 1 times 3 will give us negative 3, plus 1 times 1 times 2 is 2, plus 1 times 1 times negative 1 equals to negative 1. Then minus those numbers in red lines, okay. So we have 2 times negative 1 times 1 will give us negative 2. Negative 1 times 1 times 1 will be negative 1. 3 times 1 times 1 will give us 3. So from here we simplify. The bracket on the left hand side, we have negative 3 plus negative 1 equals to negative 4 plus 2. So negative 4 plus 2 equals negative 2. Minus bracket on the right hand side, negative 2 and negative 1 equals to negative 3 plus 3 equals to 0. So from here the determinant of A is equals to negative 2. So next step is to find the matrix A1. So remember, this is the original matrix AX equals to B. In order to find the matrix A1, so we will take matrix B, right, to replace column 1 here. So that is why we get 6, 2, 6, and then 1, negative 1, negative 1, and 1, 1, 3. Okay? So therefore, the determinant of A1, we will copy this matrix again. The next step is to copy column 1 here, and then followed by the second column. So next step, we draw blue lines and red lines. So we will multiply all the numbers in blue lines, okay? So we have 6 times negative 1 times 3 will give us negative 18. 1 times 1 times 6 equals to 6. 1 times 2 times negative 1 equals to negative 2. Minus numbers with red lines, okay? 6 times negative 1 times 1 will give us negative 6. Negative 1 times 1 times 6 equals to negative 6. Plus 3 times 2 times 1 equals to 6. So next step is to simplify the left hand side bracket. So we have negative 18 plus negative 2 equals to negative 20 plus 6, alright, equals to negative 14. minus bracket on the right hand side, we have negative 6 plus negative 6 equals to negative 12 plus 6 equals to negative 6. So therefore negative 14 minus negative will give us plus. So negative 14 plus 6, the answer is equals to negative 8. So we will do the same for matrix A2. So let's refer back to the original matrix of AX equals to B. So here, to find the matrix of A2, we will take 6, 2, 6 to replace column 2. So that is why we get 1, 1, 2, 6, 2, 6 and 1, 1, 3. Alright? So we find the determinant of A2, copy the matrix, and then followed by copy the first column 1, 1, 2, and then the second column 6, 2, 6. Draw the blue lines and the red lines. And then from here, let's multiply 1 plus times 2 times 3 will give us 6, plus 6 times 1 times 2 equals 12, 1 times 1 times 6 equals to 6, minus numbers with the red line, 2 times 2 times 1 equals to 4, 6 times 1 times 1 equals to 6, 3 times 1 times 6 equals to 18. So from here, 6 plus 12 plus 6 equals to 24, minus 4 plus 6 plus 18 equals to 28. And then we have negative 24 minus 28 equals to negative 4. So the same goes for matrix A3. We will take 6, 2, 6 here to replace column 3. So we will have 1, 1, 2, 1, negative 1, negative 1 and 6, 2, 6. To find the determinant of A3, so we copy the matrix again, copy the first column and then copy the second column here. Draw the blue lines and red lines, and from here 1 times negative 1 times 6 equals to negative 6, 1 times 2 times 2 equals to 4, and 6 times 1 times negative 1 equals to negative 6, minus 2 times negative 1 times 6 equals to negative 12, negative 1 times 2 times 1 equals to negative 2, 6 times 1 times 1 equals to 6. So simplify, left hand side bracket we have negative 6 and negative 6 equals to negative 12, plus 4 will give us negative 8, minus right hand side we have negative 12 and negative 2 equals to negative 14, plus 6 will give us negative 8. So therefore negative 8 minus negative 8, the answer is equals to 0. So finally, to solve the equations, what we do is we use the formula for x equals to the determinant of A1 over A. Alright, so we will get determinant of A1 we have found as negative 8 over negative 2. The answer is 4. To find y, we will take determinant of A2 divided by determinant of A, which is negative 4 over negative 2 equals to 2. And next, to find z, we will use determinant of A3 over determinant of A, which is 0 over negative 2 will give us 0. So that is how we use Cramer's rule to solve simultaneous equation. Okay?